Hello everyone, welcome to the Tech Talk Thursday. So I give you a short intro, what we were talking about today. We first have Joseph Pelrine here in the office. He's talking about improving estimation quality with psychology and psychometrics. And afterwards we have a talk of Remy Blättler. He's the SuperText CTO. He's currently not in the office here. He gives this talk remote, so knock on wood, this works. And afterwards, around in 1.5 hours, we are finished. If you have any questions during the talks, please write them to the chat. At the first talk, we will answer some questions. I probably have a lot of questions. We'll answer them at the end of the talk. And during the talk of Remy, it's also possible that Remy answers the questions during the talk. And we record these sessions. Of course, it's already recorded live. And afterwards, we will cut the talks into pieces and do it a bit with improvements to have better sound and better image quality. A short outlook to our next talks. The next event is 12th of January 2021. Hopefully, again, here in the office with guests and with pizzas from Google. Google usually sponsors us pizzas. We have 2 talks there. First one is about the journey to their GCP infrastructure from Leontech. And the second talk is a Kubernetes story from Lorenzo De Micheli from Commerce. And then we have a talk, the next Tech Talk Thursday is on the 25th of February. We will get some insight behind the scenes of a Swiss e-commerce shop. Probably the guys are now running on fire because tomorrow is Black Friday. And the second talk is from Andreas Schneider from TX Group. He's the security officer of the whole group. He will tell us something about DevOps. So that was it from my side. We switch over now to Joseph.
Good evening. Sometimes I wonder why I give talks about estimating. A lot of times I feel like this. where you tell somebody something and say, I have some proof with papers and stuff, and it really doesn't change. But I'm going to try to approach the problem of estimation from a different direction and might give you some ideas about, if you estimate, how to improve your process. So why am I doing this? Well, many decades ago, I used to work with Kent Beck on some of the world's first agile extreme programming projects. And one of the things we were looking for were a better way to estimate, because we knew that people liked to estimate in time, but they're not good at it. So Kent said, why don't you come up with an alternative? So I thought, okay, why not? Why not come up with an abstract scalar unit, which we called the gummy bear, because there was a gummy bear store right next to the bank where we were working. We found out that this didn't work very well. I'm not going to go into too much detail because of time. So we gave up the idea, but it was picked up later by someone else and renamed into the story point. And still, that doesn't solve the problems we have. First statement. Estimating in time is not the problem. The political consequences of estimating in time is the problem. And by using some kind of unit that's abstract, you are just avoiding the problem and you're not confronting it. So what about me? I'm a psychologist. What's this psychology and psychometrics stuff? So in my approach, what am I trying to do? There are two things that I look at, especially in terms of estimating. One is, how do we deal with the problem that our data is crap? We have bad data. What can we do with the data we have to improve the quality of it and to work with the quality that we have? And second, what do we do? How can we deal with a climate that's toxic, where there's no psychological safety, a climate where an estimate is forced into a commitment, and estimates are bargained with and juggled with by people who have no risk when they're trying to push estimates in the wrong direction? These are some of the facts that I try to deal with. So what is psychometrics? Psychometrics is what separates us real psychologists from the amateurs. Psychometrics is the study of what we call a latent construct. A latent construct is something we can't directly measure. If we were together, I could measure your weight, I could measure your height. I could not directly measure your intelligence. I could not directly measure your level of depression, for example. These are things that we can only indirectly measure, okay? The interesting thing about this is that any measurement that we have is of necessity an estimate. Since we can't directly measure it, we have to guess at it. And what we do with psychometrics, with statistics, is we use the statistics to make our guesses as good as possible. So this goes in two directions. Once, any measurement of a latent construct is an estimate, but that what we in software engineering say is an estimate, which is the amount of time we need to finish something, is a latent construct. It goes back and forth in both directions. So what psychometrics can help us with, it teaches us how to ask better questions. This is one of the things that we learn in psychology, is how to ask better questions. And it teaches us how to do better statistics on the answers that we get. So essentially, psychometric is the way that we psychologists flex our muscles, and we say, I can ask better questions than you, and I'll prove it because I have better statistical methods than you do. So what's the problem with estimation? Why are estimates normally so bad? There are a lot of reasons for that. One reason is that maybe people have a strategic interest in not estimating properly. Maybe there's reasons, it might be political or financial. Good example here. Berlin Airport. Supposed to open 2011. Do you think that there might have been some interesting reasons behind the estimates that brought them to the completion date of 2011? Just think about it. So, one of the classic reasons for estimates going wrong is something known as the planning fallacy. Planning fallacy was developed by these two gentlemen, Daniel Kahneman and Amos Tversky, and was one of the things that won them the Nobel Prize in economics. The principle behind the planning fallacy is that estimates are wrong. People tend to over-optimistically estimate because they tend to go too strongly into detail about something and tend to ignore similar cases and the data that they can get from that. Okay? So my thoughts that I'd like to share with you is, okay, if this is one fallacy, there might be a number of other fallacies. Okay? And this is still work in progress that I want to share with you, but I'd like to run this past you and see if it can convince you. One is something that I call the completeness fallacy. The idea of the completeness fallacy comes from this book, Complications from Atul Gawande, which is a very interesting book on how surgeons learn their craft. I remember reading this book, and the one thing that struck me were these questions. Do we ever tell patients that because we're still new at something, that their risks will be higher and that they'd likely do better with someone else who has more experience? When we give them the statistics about the success rates, do we ever tell them that these statistics are based on experienced people doing this? Do we ever say as a surgeon that we need for them to agree to it anyway because we need to practice these operations to get our certification? Right? Given the stakes, who in their right mind would agree to be practiced on? Right? The question is, if a surgeon comes to you, a young intern, and says, you need this operation, and you ask what the success rate it is, and he says, well, it's about 75%. Ask that question, 75%, based on which doctors are doing this and under which conditions. This is the completeness estimate. And this is where we get into psychometrics. Because the equation for estimation, it's a basic psychometric equation, is that the estimated value of anything is a combination of the true value of it, that we can't directly measure, and a systemic error, which is bias, which is influenced by the person doing the estimate, plus a random error. These three components put together the estimate. Okay? But then again, the true value of an estimate is a function of three variables. The true value of any work to be done is a function of the work that needs to be done, the person doing it, and the infrastructure, the instruments and tools available to that person. Okay? Additionally, we have something that we call a load factor. Now, a load factor, for those, I know there are a couple of real psychologists out there doing a structural equation modeling of load factor is a very good PhD project. I won't go into detail about that, but let me give you an idea what a load factor could possibly be. A load factor is any impediment that causes a task to take longer than is actually needed. Meetings that take away your time, issues with facilities, or issues with technology, the lack of tools, interference, team problems, personnel changes, unclarity about what the actual requirements are. All these things contribute to making things take longer. The problem is they're not predictable. And the other problem is they're what we call in psychology a confounding variable. They are things that will influence all the variables that we have. They'll influence the work that needs to be done, they'll influence the people doing it, and they'll influence the infrastructure and tools. And this is what makes this very challenging. Okay? So, another possible fallacy, the distribution fallacy. Okay? Another statement, think about this. An estimate is a range and not a number. Okay? Since it's not exact, it is a range. Some of you who've been around IT for long enough might recognize this, the cone of uncertainty, saying that in the beginning, as it's not clear what to do, your estimates will have a large range. The clearer things get, the more accurate it is. We could take another look at this. Statistically, you would think that if you estimate a number of tasks, and let's say each task would be estimated to what? To 5 days, to a week. That statistically, you'd expect a distribution like this. Some things will be shorter, some things will take longer. You expect the Gaussian normal distribution. Logical, but wrong. If you look at, for example, these two studies mentioned down here, which total up something like 26,000 comparisons of estimates and actuals, what we see is that it's a left-skewed log normal distribution. Take a look at this. Rarely do things take shorter. Quite often, they take longer. Right? Think about this. Where this also creates a problem is for those of you who do Monte Carlo simulations. Monte Carlo simulations, based on random numbers taken from a distribution, take their numbers from a normal distribution and not from a log normal distribution. Which means that the basis for Monte Carlo simulations in the predictive capacity for software development estimations is questionable. So another thing, the logical consequence of this is if you look at sprint capacity, that's the inverse log normal distribution. You're going to hit a wall where there's no much more you can physically, mentally, possibly do in the time available. But because of that load factor and everything, there are many reasons that you'll be doing a lot less. Okay. Another fallacy, the groundhog fallacy. Groundhog fallacy thought came to me from the movie Groundhog Day. Every day the same thing happens. One day is like the other. If you're calculating velocity, okay, velocity is normally calculated as the average, the arithmetic mean of the last n sprints, where n is a number between 1 and 5. Okay? So, sounds logical. We'll just average up the last couple of sprints and see what the average number is here. This has an implicit assumption that's also questionable. The problem here is whether these data points are equally important, whether they're equally weighted. If you're looking at the last 5 or 6 two-week sprints, you're questioning, you're essentially saying that this data point from 2.5, 3 months ago is equally valid in its predictive capacity than the data from the last sprint. And if it is, what does that tell you about your team not learning? Your team not changing. Okay. There's a solution for that that's doing an exponentially weighted moving average, where you can weight how important the last sprint is. Works very well in prediction. Since this actually is a tech talk, I do put in the obligatory code slide for this. If you want to work with this method, the best technique for an exponential smoothing is the Holt-Winters algorithm, but just do the first level algorithm, just calculating alpha, leave beta and gamma, which are seasonal and periodic trends, out, and you'll get a very nice number that will very clearly, it's very clearly stated that the predictive capacity of this algorithm is 1 for going forward, no more than that. Okay. Another fallacy, the objectivity fallacy. We're all right. We're all objective in the way we estimate. But are we? Do you recognize any of these statements? I don't understand that. Oh, I know what I'm doing. Oh, the new system will make it better. We start with 2 story points, so we can be 3 at maximum. Oh, he does Java, he'll be able to do that. Oh, don't worry about that, that's not important. Oh, that's exactly what I'm thinking. Of course, I think you guys are right. And based on the spec, these are all cognitive biases. So, the problem is, we've located at least 24 different cognitive biases that you need to be aware of. But our mind can deal with, at the most, 7 plus minus 2 at one time. Okay? So, what can we do for that? We put together a checklist of cognitive biases. You can download this checklist. I'll give you the URL afterwards. Use this when you're estimating with your team to go through and answer these questions. Is there some blind spot that you've overseen? Something that you might want to think about? Okay. So, estimation techniques. I notice I'm going a bit fast here. This talk is essentially the reduced version of a half-day tutorial and workshop, and I think I might have left a little bit out, but we'll see what we can do here. Estimation techniques. So what are some of the techniques that I use to help my teams get better at estimating? The comfort level. I prefer to estimate in time, but not only. Okay. If someone gives an estimate on something, I will ask them, on a scale of 1 to 10, how comfortable do you feel with that estimate? A 10 would be, I'll bet my job that I will need exactly that long to do it. A 1 would be, well, Joseph asked me for this estimate in front of everybody else, and I said something, but I don't believe it myself. And what this is telling you, this level of comfort, statistically, it's the inverse of a confidence interval. And what it's telling you, essentially, if you have a statistically significant set of estimates, this is your standard deviation. If it's a 10, your curve is going to be very small, going to be very accurate about that. If it's flatlining, it's going to be very difficult to say, yes, we're going to build something on this estimate. Then another technique I use, then, if somebody estimates something and says, well, my 6 or a 7, I teach the product owner to ask the question, 6 or 7, how can I help you make that number into an 8 or a 9? This is an invitation for a conversation. Nice thing about this is this is the only way you can communicate this uncertainty and make it explicit. Even though your product owners and your managers might be unfriendly people, they can still come to you and say, well, why can't you be more sure than that? That's still an open question that might allow the opportunity to engage in conversation about this. What can I do to help you become more confident, more sure about this? The question is, the answer is quite often not, I need more time. The answer is often, I need more information about this. So what are we doing here? Essentially, mathematicians here, please excuse me, I think that since estimation is a complex activity, let's imagine estimates are complex numbers. Complex number has a real part and an imaginary part. The real part is the number itself. The imaginary part is fear. Fear is imaginary, it's irrational, it's below the surface, and if we don't watch out for it, it'll influence all the thoughts and all the decisions that we make. First step I do this refactoring. I said, let's deal with the number and let's deal with the fear factor separately. Let's take fear and then let's rationalize it. Let's bring it up to the surface. When you bring fear up to the surface, what it becomes is risk. Risk is rationalized fear. There's a risk that when you estimate something, when you take a guess, that that number is going to be wrong. Yep, shit happens. That's the game that we're playing. But if you, for example, when you were younger, little child, and you told your mother, look, Mom, I'm going down the street to my friends to play, and your mother said, be home at 5 o'clock for dinner, and you said, sure, I know, I'll be home at 5 o'clock. But you were having so much fun that you didn't watch the clock, and it became 5 o'clock, and 5:30, and 6 o'clock, and at 6:30 your father came down and grabbed you and dragged you home. These bad memories, oops, if I get things wrong, I might be punished, will influence the way you think at a subliminal level. So next thing we do, once we're aware that there's a risk inherent in any estimation process, is take the next step and let's quantify this. You can quantify it any way you want. I prefer using a Likert scale, 1 to 10. You can do 1 to 7 or something like that. By doing this quantification, what you're getting is value neutral information that you can then deal with without any emotion involved in it. And then you can go back and say, okay, my level of comfort for this estimate is a 6 or a 7. And the product owner can say, okay, how can I help you get that better? If you're doing estimation for fixed price projects, you're never going to have enough time to do research. Using this idea of a comfort level, something that a lot of people do implicitly already, will help you say, well, which parts of this are high risk? High risk are things where our comfort level is low. If we have anything that has a comfort level of 7 or above, that's okay right now, just to put together a bid. Anything that's between maybe 4 and 7, let's spend the resources and the time we have to look more in detail at that. Anything that might be below a 4, we're really going to have to consider if we want to put that in the contract or not. Use that like that. So, some other techniques. Chronobiology. Chronobiology is the science of our bodily rhythms. This, my sleeping pattern from a while back. I've been having some problems with sleep apnea. I ended up in the hospital in the sleep lab, and they did research, and they found out that my patterns look sort of like this. Back in the 1950s, Nathaniel Kleitman and his colleagues found out that when we sleep, we have a rhythm, a cycle of around 90 minutes, which is known as the BRAC, the Basic Rest Activity Cycle. That's the rhythm where we have light sleep, deep sleep, rapid eye movement when we dream. It's a basic rhythm in 90 minutes. When we're sleeping, this is a sine wave because nothing externally is influencing our thought processes. When we're awake, though, this rhythm continues. But since we're working, it becomes a rhythm of cognitive decline. This rhythm is circadian, which means it's synchronized to light and dark, which means all our rhythms tend to be roughly the same. And we see this, a lot of us, in the way we work, depending on which country you're in, I'd say. A lot of us will start working around 9 o'clock, we'll go to about 10:30 or so, then take a coffee break. 90 minutes plus minus. So Kleitman says somewhere between 80 and 110 minutes. Okay? Then you take a 15-minute break or so, work again, 10:45 to maybe 12:15, and then you take a lunch break. Then you come back after lunch, and nothing seems to work after lunch. Ever notice that? The problem is that our lunch breaks need to be 90 minutes because although we're in cycle in the morning, when we come back after lunch, if we don't have a 90-minute lunch break, we're coming back out of cycle. So this is the way that I like to structure a work day. It's difficult in countries like Spain, where the rhythm is different, but in most European countries I've worked with, structuring the day into 4 units. 1 unit in the morning until the coffee break, then coffee break until lunch, lunch until coffee break in the afternoon, there to the end of the day. This technique for estimation, we call it the quattro stagioni method. And the quattro stagioni is a pizza, and this is just a reminder of Thomas that he has to order pizza for afterwards. So I said, look, if this is the way that we're going to structure the day, why don't we estimate in these units? By the way, next slide, the name quattro stagioni, this idea came from my dear friend Paolo back when we were working for a well-known racing team that we couldn't mention here. But the idea is, if this is the way that we tend to structure things instinctively, this is an inner clock that we feel. We don't know how long an hour is if we don't look at a clock. We know how long until we need a break, how long until we lose concentration. Those people who smoke know exactly how long until they need a cigarette. The fun thing about estimating using the quattro stagioni method is, let's say you do task breakdown and your tasks are at the most 1 day in length. Essentially, your estimation process is, if you come in the start of the day, don't have anything else to do, do you think, oh, if you start working on it, do you think you'll be done by the coffee break? Or do you think you need until lunch? Think you need until coffee break in the afternoon? Or do you need all day? That's estimation using our internal rhythms and using our instincts. And what happens, if you need a little bit longer, okay, take your break and maybe a little bit later. If you're done before that, interesting thing that happens is that teams tend to synchronize on this if everybody's using the same rhythm. And during my work at a number of my clients, what the teams notice is that, okay, everybody's synchronized into this rhythm. We'll do breaks together. The teams suddenly ended up having not 1 daily scrum, but 4. They had 4 simple, impromptu, informal meetings. And the advantage was that no small problem had the time to become a big problem without somebody picking it up. Okay? Think about it. It's a very simple method to do this. Something else, another method that I really think is valuable is something called reference class forecasting. This is a method that's been researched up in Oslo based on Kahneman and Tversky's planning fallacy, saying that essentially we have to look for similar cases, and we can group those cases into reference classes. This is one of Flyberg's classic papers on this concept of reference classes. If you're doing something the way that a lot of Agile people say you should do, you should have a reference story and compare everything to that. Let's avoid even getting into the problem that relative estimating is not estimating, it's comparison. If you have one reference story, what you have is a single data point that has no statistical properties. A reference class is a group of similar stories that will have statistical properties like standard deviation, like a mean, like a median, like skewness, like kurtosis, everything in there. Okay? If I don't fly much nowadays, but if I got into a plane and flew from Zurich to London, flight attendant would say, our flight time from Zurich to London is going to be 1.5 hours. How do they know that? Do they calculate airspeed? Do they run all that through supercomputers? No. They have a reference class. They collect the data on all similar flights under these conditions. And then if you need one number, you can regress towards the mean, and then you have the standard deviation of that. So what they're essentially telling you is the mean time for this is going to be around so long. Okay? And as we all know, when flights are delayed, when you get in late, it's normally not because the flight took longer. It's because of the load factor, because of problems on the ground, either at the airport you're flying from or the airport that you're arriving to. So, reference class forecasting, relatively simple. You identify ways to group your previous experiences. Find a number of buckets to put them in. Yeah, you're not going to get it right in the beginning, but start working on it. Find buckets. They should be big enough so that you have a decent sample size that you can do the statistics on, but they shouldn't be narrow enough so that they're quite specific. Okay? And then you do the probability distribution for that. What you again find is the problem with a lot of these estimates, that your probability distribution is not going to be a Gaussian normal distribution. It's probably, if you're doing estimations on software tasks, it's going to be a log normal distribution. It's going to be skewed. Remember that. So you can compare the tasks that you're going to have to do with tasks that are in the different buckets. That's essentially the way you do it. So what happens if you don't have reference classes? You're going to need to do a bunch of work in order to generate that data. There is a simple way to do this. If I'm starting teams out and we're trying to collect the data, there's a relatively simple way of doing this. And it's a variant of t-shirt sizing. If I don't know anything else about this, I'm going to define different sizes of tasks, and I'm going to map them to time. Up on the website, you will find data. I have statistics for t-shirt sizes with 100 estimations for each size in a log normal distribution with all the statistical properties. Download that, play with that, and see how far you come. Okay? So, another thing to remember. Remember what I said about log normal distributions and about the mean? What I said about exponentially weighted moving averages? If you do not have a Gaussian normal distribution, this bell curve, the median is more robust against outliers. Remember that. Use the median value and not the mean. Some other thoughts on this. Estimates have a shelf life. They have a shelf life of maximum 1 sprint. Why? Estimates are based on the value of 2 volatile variables. The first variable is the state of the system, saying essentially, if we're here, how long will it take us to get there? But as you do work, you're changing that starting point, which may invalidate your estimate, which means it might be a good idea to take a look at that. Secondly, an estimate is based on the current state of your knowledge. And as you work, and as you do other things, the state of your knowledge is changing. You're learning. You're discovering new things. But doing that may also invalidate the base for your estimates. So it makes sense, especially for the things that are coming up soon in the future, to take a look at it again, to re-estimate them. Make sure that your estimates are still valid for them. Another technique, unpacking. Something we know as task breakdown. This comes from a paper from Kruger and Evans. for those of you who follow psychology, Justin Kruger is the second half of the Dunning-Kruger effect. And what they say is that when you start unpacking, when you start taking things apart and looking at the individual tasks, you tend to get a better estimate. You tend not to be too optimistic. The more complex something is, the higher this effect is. Okay. So some last techniques on here if you're working on estimating. These techniques come from a paper from 2011 from Danziger and colleagues who were doing research into the way judges reviewed court cases and looking at their chronobiology and looking at the rhythm in which they're working. They discovered that for court cases, for prisoners who are going to be out, possibly paroled, at the beginning of one of these cycles, they would grant 64%, essentially 2/3 of them would be granted parole. At the end of that clock cycle, it was 0%. So in order to make this fair, what they found out, there are a couple of things you need to do. First, take rests. Don't make any session longer than 90 minutes. Okay? Don't make sessions longer than 90 minutes, which is a question if you're doing 2-hour meetings. How effective are the meetings? Even now, in the time of COVID, in the time that we're doing things virtually, even 90 minutes is more difficult. Right? Take rests. Allow yourself to regenerate. Secondly, you have to go in with a positive attitude about this. And glucose. Glucose gives the energy to your brain, which gets us back to the gummy bears. I don't know if I'm going to be able to change anything with this talk. I hope I've got a couple of you interested in realizing that there are other ways of things to do to help improve your estimates. This is only part of the story. The other part of the story is dealing with the psychological safety and the toxic climates that you have in the organizations. That's a topic for another talk. I'm not going to be able to get the world rid of story points and get to better estimating. But let's try to build, instead of that, build a new model that removes the necessity of having to estimate in these other units. So I'm pretty much done now. I'd like to thank a number of people. I'd like to thank my dearest friend Yvonne, who helped me with all these things and keeps my mind straight on this. Also my friend Christine, who did all the drawings for me. Julie Hendry, who reviewed this material and gave me some ideas for naming the fallacies. And Dr. Boris Altemeyer, professor for psychometrics, who reviewed all this stuff and made sure that all the numbers were right. You can find more information here at this website. You'll find this is a page on my website with data for other versions, the slides for other versions of the talk. I will be uploading this version slides sometime tomorrow. You'll also find an Excel spreadsheet and workbook. If you want to try to do some of these techniques in Excel, you'll find code for a project in R, which is where we do all our statistical work on. And you'll find a number of references. Speaking of references, anybody who knows me knows that this has a solid foundation in science. So these are some of the references that I use for this talk. And here are some more of the references that I use from the talk. And here are some more of the references I use for this talk. And if you want to go on, here's some additional references about why this stuff works, and even more references, and even more references. And since I'm not done yet, there's a lot of work that's been done in psychology over the past decades about how to estimate in time and how to deal with statistics of it. Okay? So, I'm finished. we're going to take a short break and change the camera and hook up for Remy. Questions will be taken later or sometime. Questions will be taken now. So if you have any questions, then what do they need to do?
I ask you the questions that we have in the chat, and the first one is a comment. It's from Jose Lopez. I don't know if you remembered him. He says, "Great to see you again, Joseph, after a long time."
Hi, Jose. Thank you. Thank you. That's always encouraging.
And then we have a question from... he removed the question.
Can we go to the Internet Archive and find the earlier version of that website?
I think the question was, what's your take on the no estimate movement?
Take on no estimates movement. I like and respect Vasco Duarte a lot. A lot of the ideas that came from came from his and my time working together at Nokia and doing research on estimates. And what he discovered was that if teams were estimating in story points, as long as they were breaking down their stories in a repeated manner, he found out that the correlation coefficient between the number of story points and the number of stories was so high that he said, look, don't estimate, just break the stories down small and just count the number of stories, which is a very valid technique. It's also known as small sizing. You see a lot of people like Josh Karyevsky's people at Industrial Logic and others who also propagate this technique. Break things down into smaller chunks. Once again, this is unpacking. That'll get you better estimates. Vasco went and expanded this to say, well, we don't need to estimate at all, which I think is very interesting philosophically, because it confronts us with the uncomfortable question of what value do estimates bring us? So his alternative was to say, well, let's stop estimating at all, which is valid, and he's very consequent in the way he does it. I just said that, okay, we know that people like to estimate in time, but they're not good at it. But hold it, I'm a psychologist. I can quantify not good. And then if I focus on that, I can take a look at how can make that not good better. How to make things more accurate. Right? Accurate is another question. Somebody brought up in one of the posts on LinkedIn, how do we define accurate? Accurate may be two things. One might be decreasing the delta, a difference between estimates and actuals. Another might be stabilizing the correlation coefficient. So if we can actually stabilize it and say our exchange rate is constant, we've won there already. Okay.
So there are some more questions besides lots of applause. And one is, how important is practice?
Can I go back to that slide about the surgeon? The success rate of this operation is 80%. It's open heart surgery. I've never done it before. This is the one thing they never say. It's 80% success rate when the head surgeon does it in a university hospital. But what happens if the intern's doing it out in a battlefield, right? Practice. If you don't have practice, if you don't have the data, your estimating is going to be bad. And there's no other solution besides practicing this. Another thing, and this is something that many teams are woefully lacking, is actually practicing and then comparing the estimates to the actuals. Back in the old times, back when I had hair, right, the beginning of extreme programming times, we actually had the role of the tracker. The tracker is a person who would go around and track everybody's estimates and compare them to their actuals and try to figure out why people's estimates were off and what they could do to get better at it. with data protection laws and everything nowadays, and with workers' councils, there's no way you could get away with that now. But still, you have to practice and you have to have that feedback in order to improve your craft, to understand which part of this load factor is it that's skewing you. Okay.
There is another comment and question from Philippe Defray. He says, or writes, great talk. Would learning system thinking help in generating better estimates, realizing a small chunk is actually a lot of chunks? So we might overcome our systems bias?
I don't know enough about that to have an opinion on it. One thing that I know will help, once again, is unpacking, is task breakdown. And that Kruger and Evans study has been replicated. So it's a valid psychological study. And that's what I would tend to do, because that's a technique that's a lot easier to do. And it's something that we know already as task breakdown.
We have a question from Remy that is talking later. Extreme programming is an interesting topic. What's your take on it?
I was one of the people who helped invent it, so my opinion is not objective. I think it's great. I think extreme programming is too difficult. If you want to hear more about that, there's a talk I have online called I Don't Know Anything. I can start expanding on that, but we're going to then really go over time. But extreme programming is very good, it's very valid, it's very difficult. There's a reason that Kent called it a discipline of programming. You need to have that discipline in order to do it. We used to joke that the reason we did pair programming is because nobody had the discipline to do it alone.
Good, I saw Remy smiling on the camera. So are there any other questions from the audience? See some applauses again.
Otherwise, feel free to get in touch with me on LinkedIn. Happy to continue the conversation there. Okay.
Okay, so then if there are no more questions, I would suggest that we switch over now to Remy and give us a few seconds to do that.
Thank you, everybody.
Okay, hello everybody. Thanks for having me. Joseph put a pretty high level for my talk here now, and it's an absolute completely different topic. But I'll do my best to keep you entertained for another half an hour, even though we did not follow Joseph's first idea that we should take breaks. But maybe, I don't know, it's 7 o'clock, it's what is it, 6 o'clock. So you already have a beer in your hand, I hope, and the pizza will come a little bit later. Anyway, quick word about me. This is one way I look now, this is another way I look, and on the picture on the right there, that's third me. I have a technical background, developer by trade basically, co-founder of SuperText translation agency in Zurich, and I did build like pretty much our core system initially. Nowadays I have help and people that know that stuff better than me, which is a big advantage. If I have some time, I do like to work on cars. As my friends would think, it's maybe not the best idea, but I'll keep on trying. So a little bit of background before we dive in, how we even got this whole Azure and Microsoft stuff. long time ago. As you can see from the picture, I looked a little bit different. And on the side, there's my friend Rito. I was working in New York, and we both had the same problem. We always had to send out Excel files and synchronize them by hand. And it was just a big mess. And we figured, let's invent a synchronized Excel sheet. It kind of worked out. Okay, sorry, I messed this up. And at the time, I had a consulting job at a financial software company. I had Visual Studio installed from my job, and saw, okay, Visual Studio has web forms, you can build websites with that. So when we started this, was pure coincidence that we started with Microsoft, really just because that was what was installed on my laptop at the time. We use a dedicated server from Maximum ASP, Microsoft, ASP.NET Web Forms, C#, and Rito ended up with Visual Basic. That was his part. So I think that was the last time he ever touched Visual Basic. Unfortunately, this idea with this synchronized Excel didn't work out. Rito moved on to Doodle afterwards. Doodle, I hope you guys all know. And then afterwards he started Testing Time, which is a really cool startup in Zurich, and they help find you test users. So if you have a new product or what, and you want to see if people actually understand how to use it, Testing Time can help you. I co-founded SuperText in 2005 and became the CEO there. Just a quick word, SuperText is a translation agency. We have offices in Zurich, Berlin, and LA. Whatever you need translated, your website, your app, we can help you with that. But back to the topic. As I said, coincidence, Microsoft was installed in my laptop. So this shared Excel stuff was built on Microsoft, and because that was there, we continued on that track for SuperText. Originally, I was actually more of a Java programmer, so could have gone either way. We did use MySQL in the beginning, Maximum ASP as the host. Unfortunately, at that time, I didn't know about 9. Who knows where we would be nowadays if I would have met Tom a little bit earlier. And we had Fastmail. That was one of the first email providers that had IMAP. And soon after, Gmail came out with IMAP. But yeah, it was too late then. Over time, we switched MySQL to SQL Server. And the big move at the time was from having a dedicated server where you really just had like physical box that was somewhere in a data center. When we moved to Azure, and because everything else was Microsoft already, we figured we might as well move Fastmail to Office 365. And with Office 365, we got Active Directory. For those who are not in the Microsoft world, Active Directory is basically the central user administration and whatever, like all your users are stored in Active Directory with all their roles and what they can do and what not. Initially, I think it had quite a bad reputation, super complex, but luckily for us, with Office 365 and with Azure, the administration has been quite easy and nice. So for my experience with it, it's been pretty good. With that said, this is Azure, Kubernetes, and whatever talk. Personally, I really don't know much about Amazon Web Services or the Google Cloud, so I don't really have much of a comparison. What I can tell you is how we deal with Azure, things that are great, things that are not so great, or since the call was called Zonk, it's more of the focus of the stuff that is a bit on the complicated side. One of the cool things that I want to start with is user management, and that includes single sign-on and this is basically the Active Directory again. Directory for free if you have Office 365, and maybe just for those who are not familiar with Office 365, Office 365 is pretty much the same thing as Google Cloud if you have email and docs and whatnot, with the advantage for some people, I think some people would say it's a horrible idea, but you do get the Office desktop tools with it. And so since we do have Active Directory, it's pretty much at the heart of what we do. We can use Active Directory for our own online management system that we've built. The one here on the left, we use it for our HR tool. We use it to log into SQL Server, use it for SQL Azure. SQL Server and SQL Azure is not quite the same thing. We use it for our Windows servers, for DevOps, and also to log into our laptops, cell phones, tablets, what have you. So really, pretty much our whole organization is controlled by Active Directory, and you don't need a massive IT team to set this up and control this. We are 10 people, most are developers, so they don't really take care of this. We have 2 people in support that kind of manage this, and we get some external help occasionally with that stuff. But that whole Active Directory story, I think, was for us quite a big benefit, pretty cool. But as usual, there are some carrots. We think, okay, we have this Active Directory. Turns out Active Directory and Azure Active Directory is not actually the same. So if you want to log in to a Windows server or a SQL server, then Azure Active Directory is not enough. You need an additional service that you have to configure. Azure Active Directory domain services, and it's by no means obvious how to configure this thing. We got it working with some external help, but for me, a bit of something I don't understand. If you build Active Directory in Azure, why can't you use this out of the box to connect to all existing SQL Server and whatever what you have from Microsoft? So that has been some Microsoft stuff I don't understand. Another real highlight, I think, from Azure and Microsoft is security nowadays. I know they had a really bad reputation, but if you have Azure and especially also Office 365, they do have different subscription levels. If you really want to get the whole security suite integrated, you need a pretty expensive subscription level. The one we have is E5, and that costs about $50 per user. But it's cool. So this page here is integrated, so you can run simulated attacks. For example, you can send out emails that have malware. You can send out phishing mails. You can send out programs that have viruses in them. Obviously, all things that don't do anything bad, but you can test how your users react if they actually get something like this. And it's quite interesting if you see and you send this out and then you see 50% of the people opened the file. So you would have a virus on your desktop now if this would have been for real. We haven't used it here yet. As you can see, 0 of the users have completed the training. And I hope not too many of my employees are watching this show, because we actually do want to try this out pretty soon. This is another dashboard that you get that gives you ideas, or not ideas, but recommendations on how you should configure your system. You can see our security score at the moment is not very high yet. We've really just started pushing our security into, hopefully, higher numbers. We are working on the ISO 27001 certification. So for that, I guess our secure score needs to be a little bit higher. But it gives you a list of all the stuff that you should configure or can configure, so that your security just so that your security is higher. If you would have to figure this out all by yourself, or just even know all the stuff that you can configure with Azure and with all these Microsoft services. If you're not a sysadmin, I think you're completely lost, and nobody in our company is a sysadmin. But with tools like this, makes it quite easy. This is an email we get for our SQL server, for example. Also comes and says, hey, okay, there's security checks that your guys are failing. This is a development server, so it's not as bad, but still 19 failing checks. Maybe there is room for improvement. But the cool thing is you get these emails and then you can go through all these recommendations, and maybe they make sense for you or not, because it's not everybody has the same situation, but you can work it down and try to make this as secure as possible, and you don't have to go through books and websites and whatever to find that stuff. And the first screen I showed was for Office 365. You basically have the same thing for Azure. Also gives you a massive list of all the things you could improve to get higher security score. One thing that I thought was pretty cool about Office 365 that I have not seen anywhere else is the combustion chamber. And it's basically a virtual machine, and all your emails get opened in a virtual machine. And if the email has an attachment, let's say it's a Word file, they open the Word file in that virtual machine, wait for a few minutes, and check if anything unusual happens on the virtual machine. And with that, you can actually catch viruses that nobody knows about it just by trying out what happens. No, and this happens automatically. It delays the email delivery by a few minutes if there are attachments in there. Otherwise, makes almost no impact. But it has proven pretty valuable for us in the past, especially since we're a translation agency. We do get documents from clients all the time. And it's not the first time that we get documents from, or at least under the client's name, or from a client that got a virus and we caught it with this system, and otherwise likely we would have had it on our hard drive now. Now, a bit on the other side is our story with Kubernetes. It all started with basically setup. When we moved to Azure, we had a dedicated server, and the easiest way to migrate to Azure was getting a virtual machine, like a full virtual machine. You can log in, it's a Windows server, it has IIS, that's the web server. And initially, we only had the more yellow things on the left side, our admin portals built with web forms. The customer, the freelancer portal was built with MVC. It's all .NET stuff, and the API. And those things were built with the traditional Microsoft.NET framework. And then came Microsoft.NET Core. And we started building our new stuff with .NET Core. And on IIS, running this stuff side by side wasn't a problem. But we really wanted to get rid of the whole Windows server and move to Azure App Services. First of all, so that we can script the whole setup process. Our Windows server virtual machine was all set up manually. And with Azure App Services, you can basically, I don't know how it's called on Amazon, but I think it's called similar. But I think there you can just upload a jar file. That's it. Don't have to take care of a server, no updates, nothing. Security out of the box, scalability out of the box. Sounded great, exactly what we needed. But then, turns out, you can't run ASP.NET Core and the old ASP.NET framework in the same app service. So if we wanted to do that, we had to do basically two, couldn't have run on the same website. And we said, okay, what can we do? Solution containerized app services, where you basically put your apps in Docker containers, and then you can just run multiple Docker containers side by side on the same app service. A little bit more complex in the setup, also more maintenance, because you do have to maintain your Docker container images and stuff. Got a working prototype, all already pretty optimistic and happy, but no, turns out these containerized app services weren't available in Switzerland. And one thing I forgot to mention, the whole thing why we do this exercise is also at the moment our server is in Dublin, because when we moved to Azure, there wasn't any Azure services in Switzerland, but now there are. And but containerized app services wasn't available, called Microsoft. When do you bring this to Switzerland? Nobody knew, there was no date. So not a dead end. And then I talked to Tom during one of our CTO meetups, which, by the way, I would recommend to any CTOs that are listening here. If there are any, join us. It's a pretty cool meeting every 3 months, Thursday morning. And so back to topic. Tom was all super optimistic about Kubernetes, that this will solve all your problems. And I figured, okay, that sounds cool. Let's give this a try. But I would have to say, I mean, just out of from far, it did look more complex from the setup. It's definitely a little more maintenance, and nobody at SuperText had any experience with Kubernetes. We did get there now. We have this prototype up and running, and it's running in Switzerland. But as usual, what happened is that Key Vault, that's a Microsoft solution for secrets where you store your passwords and all that stuff, was not out of the box supported by the Kubernetes instance that run on Azure, or at least not on the standard one. We had to upgrade to a different, sometimes of a higher, I don't know the name anymore. But yeah, not there by a click. And then SSL. SSL problems. Turns out the one we have now, the Kubernetes version that runs on Azure doesn't support Kubernetes, doesn't support Ingress. But they said, okay, there is a preview, you can use that one. We are trying that actually right now, but that's not up and running yet. And the preview and Azure is always a bit of a tricky thing, because you never really know where it's going. So even with Kubernetes, our Swiss server dreams have not been completely achieved, but I think that's definitely where we stay and where we want to continue. But it's, yeah, it's always, it looks great and easy in the beginning, and then once you go down to the details, it gets very tricky. Another thing that's a bit on the similar side with Azure is backups. For example, for virtual machines, you have backups. You can basically, it's one click, say I want the backup, you get a backup, you can say how many times, whatever. But then, like, okay, now maybe we should try to restore it. And you can restore it with a click, but the VM will not run on the same IP address anymore afterwards. And if you've set up your DNS, usually with an IP address, then you're toast. Oh no, you're not toast, you can reconfigure your DNS, but that might take hours until everything is restored, or like all the DNS addresses are updated. So it's really not just backup and something goes wrong, you click and your backup is back up and then your server runs again. You can do it with the same IP address, but it's quite a complex manual process. And then, for example, blob storage, that's just what we use to store all files and whatnot. There's just no backup option whatsoever. So we even looked for, there are a few commercial solutions out there, but they were kind of weird. So we actually had to build our own backup solution. And when we switched to the cloud years ago, having to build my own backup was really the last thing I had in mind. And I figured that should have been something that is solved if you move to a cloud solution. Another topic, innovation and documentation. The cool thing about Azure, they are really developing very fast. So compared to what was there years ago when we started to what is there now, it's actually really awesome. And all their services do change and improve very quickly. And I mean, the success from Azure, I think it's compared to, I think they almost caught up to Amazon, and they're definitely far ahead to Google, at least not in terms of, I know Tom is using Google, but not in terms of how much revenue they have. I think they're definitely up there and they really caught up. You get the latest version of everything, high performance, scalability, you have all that. Swiss Cloud, I think that's like a big advantage. I think Google has Swiss Cloud, but as far as I know, Amazon doesn't have yet. But on the negative side, for example, we used a SQL Server, or we wanted to use SQL Server when we moved to Azure, and then there was like, okay, Azure, what the native Azure solution is Azure SQL, but then there is still SQL Server, and then there is managed SQL, and you're like, what's the difference? And so it turns out they're all the same, but they're all a bit different. And then you have to figure out what is the right solution for you. At the moment, we are using Azure SQL, and in parallel, we're using SQL Server. But likely we'll try to move from SQL Server to managed SQL, but we'll see. And obviously, the problem that you have with something that develops so fast is whenever you're trying to use it and you're looking for documentation, the documentation you find is always out of date. And then you're fighting through the different documentation and blog posts and what you find to figure out how does this thing work. And it's a bit frustrating sometimes. And something that I would not have expected moving to the cloud is that you use a service and then they release a new service. So basically we use their virtual machines, and then they came out with like modern virtual machines. So they called the old one now classic virtual machines, but there's no upgrade path. What you have to do is pretty much start from scratch, set up your server new. There's no button, there's no scripts you can click to upgrade from the old one to the new one. And maybe this whole preview thing is, I don't know, they might have learned that from Google. Whenever you want to use something that's a bit on the cutting edge, then it's in preview and it changes and it's a bit just unstable. And what we learned with these containerized service, and I think a lot of other stuff, Azure does have data centers in, I don't know how many locations in the world, I think like 40 or 80, which is great, but every data center has a bit of a different set of services that they have, which makes the whole thing, again, pretty complicated when you want to have a data center, when you want to use multiple data centers, for example. And then the thing that happened to us more than once is we had our service or whatever, and they came out with a new version or with a new feature. And then, of course, that feature was not available on our service. And as I said, on top, upgrades were not possible. So you have to really go through the whole thing again. This is how our Azure SQL Server looks like, the configuration part. And you can see here, I'm not sure if you can see my mouse, but like there's different levels of this SQL Server that you can rent. So there's basic, standard, premium, then there's general purpose, hyperscale, business critical. And with general purpose, for example, you can say provisioned or serverless, how many cores and data. And it's a real, like, you need a PhD to figure out what's the correct server for you. What's the difference between provisioned and serverless and basic and standard and general purpose? And I don't think we really figured it out. We usually try something and see, is it fast enough? Okay, no, maybe we'll switch to something else. It's always a bit of a guessing game. And then this is for a virtual machine. there's 48 different configuration options for your virtual machines that are available for these classic virtual machines, and then there's 84 other options that are not available. Which one is the right one for you? Maybe the price, you select one, but I mean, I don't know, something simpler that you can just say how many cores you want, how many gigabytes, is maybe something that I would think is easier. Another typical Microsoft problem, I think, we tried to script our whole Kubernetes, or basically the setup process that we have now. And you can, it's awesome. You have like a PowerShell, or then that's a problem, the Azure CLI, where you can really script the whole setup process from start to beginning. But as always, there's two solutions, and no one really can tell you which one is better, which one you should use. And then you start using one. We decided Azure CLI, you can script 99% of the features, and then just a tiny last bit, oh no, that's not available in Azure SQL. Or you have to use PowerShell for that. Or if worst case, it's not available in anything and you have to do it manually. And again, like with this scripting stuff, most examples that we found were outdated. Yeah. So the final words, all in all, I think, and I'll note that I was a bit on the negative side here because of the title, I was talking about the Zonk of Azure. I think the whole thing is pretty cool if you are in the Microsoft world, as we are, from Office 365 and Active Directory, Visual Studio, C#, Windows Server, SQL Server. If you're on that side, the stuff works together and it's pretty powerful. It's nice, but it's a constant fight with version documentation and missing features. That's it from me for the moment. I'm not sure if there were some questions.
Currently there are no questions. We'll see if we get some questions. Waiting a few seconds. Because there is a delay of about 15 seconds. So maybe Remy is also open for suggestions.
Yeah, no, I mean, we did think about switching, but we are so deep in the Microsoft ecosystem. I think it would be pretty painful process to switch from Microsoft to something else. As I said, I know this talk was a bit on the was more about the problems that we're facing, but all in all, I think they do have some really cool features, and whatever you need, it is there. Which and as I said, I don't really know Google Cloud or Amazon too well, but I think the width and availability of services that Azure has is pretty awesome, especially if you combine it with Office 365.
There is now a question from Stefan Bierer. He asked, which SQL solution would you choose on Azure if you started today?
Yeah, I would still go with, as I mean, we used Azure SQL. I would still go with Azure SQL again, because that is their cloud native, basically, version of SQL Server. And SQL Server itself, or even managed SQL, is really only if you need 100% compatibility with basically the vintage SQL Server. We have some apps that need SQL Server, and for those, Azure SQL unfortunately wasn't enough. So if you're in that situation, you don't really have a choice. They do have Cosmo DB as more of a JSON document DB. We've tried that out with the workflow system that we're trying to introduce. Unfortunately, the compatibility wasn't good, or the drivers weren't ready. So we also had to switch back to Azure SQL for that. But I think for some situations, if you really want a super scalable distributed database, Cosmos DB could be quite cool. But for us, at least for most tasks, maybe not the right solution.
Okay, so there are no other questions. So I should say thank you very much, Remy, and we leave you out again and switch back to Zurich. So, bye.
Sounds good. Thank you. Bye.
Okay, so that was it with the Tech Talk Thursday. Thank you very much for watching. And if you have any suggestions for us to improve, let us know. And if you like the talk, please click the like button. And if you like our talks in general, please subscribe down below. And that was it for today. See you next time. Bye.